Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 6 of Gardeners of the Galaxy, a podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. Coming up later in this episode, we've got a fascinating interview with the people behind the Astronematode mission, which sent tiny predatory worms into space. Before we get to that, the exciting space news this week is that in the early hours of Saturday morning, that's for me, it was late evening Friday local time, Northrop Grumman launched a Cygnus resupply spacecraft to the International Space Station. NG-14 is due to dock with the ISS today, and it has some exciting plant experiments in its payload. For space gardeners, the most exciting part of the payload is a radish experiment. The Plant Habitat 02 experiment aims to grow 2 sets of radishes in the Advanced Plant Habitat, or APH, which is larger than the veggie growing system. Radishes are an ideal candidate because of their quick growth, and the experiment will explore how different light and soil conditions affect growth. The results should help to optimise radish growth in space and provide an assessment of their nutrition and flavour. The ultimate goal is to develop ways to produce food in space and help sustain crews on long-duration missions, including those to the Moon and Mars. I'm hoping to have the scientist behind the experiment, Dr. Carl Hassenstein, on an upcoming episode of the show, so stay tuned for that. Also on its way to the space station is an experiment to make use of the new spectrum imaging system. Veggie and the Advanced Plant Habitat allow researchers to grow plants to a reasonable size, but a lot of space plant experiments, and biology experiments generally, take place in small petri plates. Photos taken during the experiments allow researchers on the ground to see their progress. The Spectrum 001 investigation is about improving those images for a better understanding of biological responses to the stresses of spaceflight. Now, seeds and plants have been going into space for longer than we have, and scientists all over the world are clamouring for soil samples from the Moon, Mars, asteroids and anywhere else in the solar system. But did you know that no Earth soil has been into space? That all changed when some good old-fashioned Earth dirt blasted off on NG-14. Earth soil isn't inert or sterile, it's a living ecosystem. The idea behind the Soil Health in Space investigation is to find out what happens to that environment in space, specifically the growth of bacteria and fungal mycelia, and how that affects the way the soil aggregates, clumps together. A better understanding of how spaceflight affects soil microbial activity could help us to grow food crops on space missions. It could also lead to new soil conservation and management techniques on Earth that would help increase agricultural yields. And for all this plant-related excitement, what's getting the most press attention? The new space toilet. It will allow space gardeners to boldly go in a more water-efficient fashion. There's also the ammonia electro-oxidation experiment, which will investigate converting the urea in human urine to ammonia. The oxidation reaction breaks up the nitrogen and hydrogen molecules, producing nitrogen gas, water and energy. This kind of system could provide an innovative water recovery system on long-duration missions to the Moon and Mars. It also has the potential to provide vital drinking water in remote and arid areas on Earth. I'm not 100% sure I approve though. I can't help thinking we should turn that pee into plant food instead. Northrop Grumman's tradition is to name each Cygnus after an individual who has played a pivotal role in human spaceflight. The NG-14 capsule is named the SS Kalpana Chalwa in memory of the NASA mission specialist who died in the Columbia tragedy in 2003. In the extended version of the show for patrons, I'll tell you more about Kalpana Chalwa and how she became a space gardener. If you'd like to become a supporter, I'll tell you more about that at the end of the show. Astronematode was the first biological control experiment carried out in space. Organic gardeners listening to the show may already be familiar with biological controls, which can help defend plants from pests. They're a way of using natural predators to control pests rather than resorting to chemical pesticides. In the UK, for example, we can buy a product called Nemoslug, which uses nematodes to kill slugs. The nematodes produce a toxin that kills the slug, and then they use its body to feed their babies. Lovely. Would nematodes still be able to find and kill their prey in microgravity? That's the question that Astronematode set out to answer. So I am pleased to welcome Dr. Fatma Kaplan and Cameron Schiller from Feronym onto the show to talk about their work on the Astronematode mission.
Hello, welcome to Gardeners of the Galaxy. Thank you for coming on the show to talk about your work and the exciting discoveries that you've made.
Hi, I am Fatma Kaplan, CEO and founder of Feranim, and thank you for inviting us. I also have my co-founder here.
And I'm Carl Schiller. Thank you very much for having us on your podcast.
You're very welcome. So if we jump right in at the beginning, can you explain a little bit about what Feranim, your company, does?
We are using pheromones from nematodes. These are microscopic roundworms to control agricultural pests.
Okay, so I mean, that's important for agriculture on Earth, isn't it? Because it helps us grow more food for people without using a lot of chemicals?
Yes, that's the goal.
Can you tell me why you decided to send nematode worms into space?
Let me start. This was one of the most exciting projects I have ever conducted.
I imagine, yeah.
We had a grant prior to this project to develop the nematode pheromones for agricultural pest control. Then we met ISS project scientists, and they mentioned about what they do. And we thought this was really great opportunity to send the nematodes to International Space Station.
Yeah.
And one of the requirement was for this project, it had to have an immediate Earth application.
Okay.
So we were lucky because we had an immediate Earth application.
Really?
Yes. Since we are working on the product formulation and for Earth and just sending the nematodes to space to see actually whether they could go through the sand and finding the target insect. But for them to get out of their insect host cadavers, they have to have dispersal pheromone.
Right.
It is one of the key that helps them to get out of the insect host cadaver. Now, I kind of jump into something that I didn't mention before.
Okay.
So the nematode we are working with, the first one they're called beneficial nematodes. They're commercially used to control insect pests. These are the good guys.
Yeah.
Not very many people know about them, but they're good guys. And in the U.S. Environmental Protection Agency considers them so safe that they don't require any registration as a biopesticide.
Okay.
So there are companies in Europe and Germany and in Netherlands, they produce these nematodes. There is one actually in England too, to control agricultural pests. And we found that the commercial beneficial nematodes are not reaching to their true potential.
Ah.
And it turns out that one of the behavior pheromones control is dispersal and infectivity.
Oh, okay.
So this pheromone effect goes away by the time farmers reach, these nematodes reach the farmers. With our first product, we remind them that they're hungry. They need to go out and search for a new insect.
Okay.
So this is our first product called Nemestin. And this is what we were working on. And we had immediate application. We wanted to know what kind of pheromones they would produce in space because it's a stress factor. There are a number of things.
Yeah.
If they could actually get out of the host cadaver. And if they did, we thought they might be producing pheromones. So we can look at those pheromones. Even if they couldn't, that was an important thing.
Yeah.
Because we wanted to know what kind of pheromones they produce. Were they equivalent to the ones they produce on Earth? So we could compare. It could be better. We could get lucky and it could be a better mixture. So we could immediately add those things to our pheromone mixture. So we had an immediate application. And besides, it was space. How could you resist that?
If you got the opportunity to send something to the space station, would you?
Absolutely. Yeah, you don't turn that down.
We thought, wow, we really hit the jackpot personally.
You did. You really did. Okay, so your Astronematode mission, you sent your intrepid nematodes up to the International Space Station. They had a relatively quick trip up there, and then they came back down and you analysed the results. So you've published a research paper about your results, and I will put a link to that in the show notes so that people can read that if they want to. So what did you find? What did you discover with Astronematode?
We expected that everything would go perfectly fine.
Yeah, after all, Sea Elegant has gone up to space so many times. They've lived every time.
They survived the Columbia shuttle.
Yeah.
I know, they're indestructible, but yeah.
Exactly.
What we thought, we were going to have alive nematodes no matter what. We thought nothing could go wrong. But, we had many of the things we kind of thought about and had backup experiments. And we thought, well, what if they couldn't get out of the insect house? Because now they're floating, we don't have the gravity, on Earth we have the gravity, they could, use
What if
other
they couldn't
forces.
actually reproduce? What if there are lots of what ifs that we had to control.
Absolutely, yeah.
So we had all those things, and since we also picked a life stage that is more tolerant to everything. It was infective juvenile, which was equivalent to Dowers in C. elegans, the model nematode, which has been sent to space a number of times, and we thought we can't really go wrong too much with this one. So we thought they will come back Earth alive. So we had one control. It was just sent into gel. They didn't infect anything. They just traveled for 30 days, 33 days, and they come back.
On the space station.
So they came back. But one thing we thought is they would be a little bit more sluggish when they come back. So that's what we were expecting. But we thought it would, the ones on Earth would be fairly sluggish too. To our surprise, those were very active. We thought 33 days in space, they would be deacclimated to gravity when they come back, and the Earth would feel very heavy, so they wouldn't be able to move their muscles. So they would be acting like dead, but not really dead. No, to our surprise, they were very active. They said, wow, this was supposed to happen. But we said, okay, they're still alive, so no problem.
Good stuff. Yeah.
Then we looked at one of the first experiments just to see whether they were able to emerge, and we were able to see the nematodes. They were very active too. We thought, well, apparently the gravity wasn't a big deal. That particular one was the first infection. So they were infected on Earth, but they completed part of their life cycle in space. And then they emerged, and we didn't have anything else, so they were stored in sand, which was good. They were alive. We said, yes, that's good. This is what we were expecting. And then we had another experiment so they could go through the sand and find the target insect. That particular one frozen to make sure that we actually see them inside the worms,
in
the
action.
target insect that we know they infected. All three of them. This was really great. We said, yes. And then we thought, now, could they actually completely develop their life cycle? Because some of the eukaryotes cannot. I think it was in the birds and the chickens. So some form of the development required gravity. But based on C. elegans, we thought they should, because C. elegans was able to complete a couple of life cycles in space. And we thought those would be alive. Then those were very interesting, because all of a sudden we saw this. It is actually on the publication too. This is half broken nematodes. It almost looked like they were bent and they were not moving. We thought, oh, this definitely looks dead. And we thought, okay, well, maybe it could be, not to be able to adjust the gravity, but they were definitely stressed. We could tell, because when they get stressed out, they kind of bent their tail, and they were bent-tailed nematodes. So we immediately look at their control. They had the corresponding control. The corresponding Earth control was alive. There are a number of scenarios why they're dead, and maybe they ran out of oxygen.
Yeah.
And so we immediately look at the Earth control. They were fine. And we thought, well, maybe just being in space, and our other control was fine. We thought, maybe it could be gravity, but there was one other thing that, in space, there's so many things happening. It is not just the gravity when we send them there. How water behaves is different. And in plants, it was shown that there could be some face-induced hypoxia. Yeah. So we think there could be multiple of things, what's happening. We also looked at, since we sent them, we had a really great opportunity that we could look at their symbiotic bacteria. Did it change anything, how much they have? That also has Earth applications. And we had differences in that one. So we actually had a lot more questions beside the answer. We did get the good answers, but we also had a lot more questions for follow-on studies.
Okay, so is there going to be a second Astronematode mission? Are you thinking about that?
We think so. Yes. We are working on another proposal.
Excellent news. Yeah, you'll have to keep me posted, so we'll catch up with you when that comes to pass.
Oh, definitely.
Yes,
so, I mean, that's absolutely fascinating that you've sent these tiny little worms into space, and they've thrived, and you've learned so much. So that's really brilliant.
Thank you.
So I would like to ask you my fantasy space plants question. So Cameron's had a little bit longer to think about this. So if I ask you first, Cameron, have you got a favourite plant that you would like to take into space?
Well, I'd take a potato.
You're going to do a Mark Watney.
Exactly. And, French fries in space. How can you beat that?
I hate to disappoint you, but you can't fry things in space. On Mars, you probably manage on Mars. So
I'd have to figure out how.
yeah, but in space, because without gravity, sort of the convection
Right.
and things is tricky. But yeah, I like your thinking. Yeah, I say from one potato you can grow quite a lot. So yeah, okay. How about you, Fatma?
That's what I was thinking too. Potato, it's very efficient with photosynthesis and it produces a lot more edible. And I love potatoes and the French fries, but it's not just a French fry.
I thought she was going to go for strawberries.
Ah.
I could have taken many things, but I think for the survival wise, I will take the potatoes.
It's hard to choose just one. Okay, so I mean that was the end of the questions that I prepared. Have you got anything else that you would like to say?
Sure, there is one thing actually many people do ask us, why do you need a pest control in space?
I did think about that actually. But go ahead and let's hear your answer to that question.
So what we used to say is, NASA has a mission to have the routine trip to space.
Mm-hmm.
And we thought the pests will go there not intentionally, but unintentionally.
Ah, yes.
And when they go there, what do? We can't really use the chemical pesticides because we have limited air.
Yeah.
And use chemical pesticides, then we can't really open up the windows. If you do, we're going to be holding our breath for a long time.
Yes, and you'd contaminate the water supply as well, probably.
Yeah, so we have to have eco-friendly solution, and we think the biological controls are going to be the first ones.
Yeah.
To be there. And this was actually a great experiment on that aspect too.
Yeah.
Now we can actually show the biological control agents can work. And also on top of it is a two symbiotic organism can cooperate in space.
Yeah.
That we didn't really know. It was also another surprising finding.
We did the beneficial nematodes themselves have a symbiosis with a bacteria that they use. And the fact that symbiosis was able to function in microgravity was actually really amazing.
Yeah. It's amazing what does work in space, actually.
Mm-hmm. Yeah, it is.
Okay. Well, that is absolutely fascinating. So thank you so much for coming on the show and telling us all about it. I wish you every success with your future research. And as I say, if you do have a second Astronematode mission, then come back on the show and you can tell us about that as well.
We'll do that.
Thank you for inviting us. We really enjoyed it.
Thank you so much.
Thanks again to Dr. Fatma Kaplan and Cameron Schiller from Ferronym for that fascinating insight into the Astronematode mission. If you'd like to know more, then I'll put some links in the show notes for you. That's all we've got time for in this episode. If you sign up as a Patreon supporter, you'll have access to the extended episode, including the story of how Chalwa became a space gardener. For those of you who are in a position to support the show financially, I have set up 3 levels of support on Patreon. $4 a month will help me pay for the things the show needs, which includes hosting and equipment costs. The higher levels of support will allow me to spend more time on the show. So for $7 a month, you'll get extended episodes, which will have extra content and longer interviews. For $13 a month, you will also get extra bonus episodes. If you're based in the UK or in Europe, then Patreon lets you pay in your local currency. If you'd prefer to make a one-off donation, then I have a virtual tip jar on the side of my website, which is theunconventionalgardener.com. That's where you'll find the show notes, lots more information on growing plants on Earth and beyond, and how to connect with the show on Twitter and Facebook. If you're enjoying Gardeners of the Galaxy, then please take a moment to like, retweet or share the link so that we can grow our Space Gardener community. And you can always leave a nice comment on my blog, which gives me a warm and fuzzy feeling. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control. We are confirming termination of your signal. Unfortunately, we have also lost your movie requests, so we have picked you The Martian and Frozen. Uplink commencing now. Mission Control out.